Okay, question number 9 says, how much money should be deposited in a bank paying an interest rate of 6% per year compounded quarterly so that at the end of 10 years the accumulated amount will be $2,721? Okay, so in this case we have the accumulated amount A. We are looking for how much money should be deposited. So we're looking for the principal. Our rate is 6% or 0.06, and our compounding period is quarterly, so M is 4, and our time is 10 years. So again, there's nothing wrong at all with using either one of the compounding formulas. I just particularly like to use the one that's already solved for what I'm looking for. So I'm looking for present value here. I'm going to use the present value formula. If you notice, all that's different between the accumulated amount formula, the future value version, and the present value version is the exponent is negative in the present value and is positive in the future value. And that all has to do with if you're trying to solve for this right here, you end up having to divide all of this off. Dividing would put this on the bottom, and when you move something from basically the top to the bottom, the exponent changes sign. So that's all that's different. I'm going to go ahead and use the present value setup for this because I can do P equals A, which is 2,721, times the quantity, 1 plus the rate, 0.06, over M, which is 4, to the 4 times 10 power. So this is 40. I'm going to just go ahead and type that in when I go for it. So look, I gotta type in then 2,721 times the quantity, 1 plus 0.06 divided by 4 to the, and as long as I'm only typing in one value, I don't need parentheses, I'm going to say to the 40th power, hit enter. And it comes out as $4,935. Oh, I made a mistake, and this didn't make any sense. Notice what I left out. I'm trying to find the present value. What should I deposit now so that I would end up with this amount later? And I'm getting that I should deposit in almost $5,000 to have $2,700 later. Well, that doesn't make any sense. And hopefully you notice what I left out, which was the whole key to this formula, which is the negative in the exponent. So that doesn't make any sense. I'm going to leave that there, though, so we can realize that Carrie did something incorrect. I'm going to do a second enter. The only thing that's different is that this needs to be a negative 40. So negative 40. And let's see if we get something that makes actual sense here. Now that makes sense. So $1,499.98 invested now to have $2,721 later. So that makes logical sense. That is your best friend whenever you're doing these finance formulas. Is the hardest part is figuring out which formula to use, and your best friend is the logic at the very end of, does that answer even make sense? Is it even reasonable? I always take a second to look at that, and half of the time I realize I've made a very silly minor error and I can go back and fix that. Otherwise, I'd be entering things that make absolutely no logical sense. So again, if you wanted to on this one though, there's nothing wrong with using this version of the formula, as long as you put everything where it goes. So if you put in the 2721 over here, leave this blank, you put in the rate over M, and this one is positive. So if you do positive 4 times 10 here, what you end up doing is calculating all this out and then dividing it to the other side, and that division process is the same, has the same effect as this negative sign over here does. So you'll get the same answer either way you do it. It's a personal preference. I'm trying to give you options. So again, if you do like the Newton instruction, they're probably going to use this method. They don't seem to prefer the separate formulas. They like using one formula and then subbing in wherever you need to. I like using separate formulas because it just helps me to keep everything straight. So options for you. I don't care how you do it. What I will be looking for though is I will be looking for a setup like this where you show me the equation that you're using with all the numbers subbed in where they go, and then a final answer. So whichever one you use, I would be looking for either this or this, one of the two, and then I would check your final answer along with that. So again, Newton will only check your final answer. I'll go back in and check your equation. Whichever version you use, I don't care which one you use. Okay, so number 10 says, suppose you have $1,000 to invest for 5 years, and there are 3 accounts to choose from. Account 1 offers 5.9% compounded annually. Account 2 offers a slightly lower rate, 5.8%, but compounded quarterly. So less percentage, but more compounding. Interesting. And account 3 offers an even slightly smaller 5.75% rate, but an even higher, the highest, continuously compounding periods. Which account would you choose? So if everything is the same across the board, we know that compounding more often is better. But what if everything's not the same across the board? So on these, the percentages keep going down while the compounding rates keep going up. So it's kind of like, what thing is going to win out? Well, let's go ahead and just do all of these. These are all, we have our p-value, we have our time, and we have different rates and different compounding periods. But we definitely need to use the future value for all of these. So the first one would be set up as A equals the principal times 1, the quantity 1 plus, this rate is 5.9%, so 0.059, over, it's only being compounded annually, so 1 time per year for the 1 times 5 years. I'm going to set them all up and then go back to them. Account 2 is the same type, so A equals 1,000 times the quantity 1 plus 0.058 this time, and then compounded quarterly, so 4, and then the 4 times 5 quantity power. Now 3 is a continuous, so I'm going to use that continuous formula, which is A equals P e to the RT power. So principal still 1,000, e to the, its rate is 0.0575 time, and then times 5 up in the exponent. So I'm going to set them all up and then go ahead and calculate them each. So let's see, for account 1, we have 1,000 times the quantity 1 plus, I don't even need that 1 down there, but just, I'm going to go ahead and put it under here, because then whenever I go, I'm going to do my next one, I'm just going to do a second enter, and I'm going to change the values a little bit. So I'm going to have 1 times 5 up there, and I get $1,331.93 rounded to the nearest cent. The reason why I went ahead and typed all those ones even when they weren't necessary is so that when I go back like this, I have a space to change that M value, because that needs changed, and then the only other thing that needs changed is that 9 needs changed to an 8. So I just feel like that saved me a slight little bit. So let's see, that gives us $1,333.65. So this one's a little bit better so far. Now let's check out this third account. Is the continuous compounding going to outweigh this slight drop in percentage rate? I don't know. So this one I need to do the second E, and then I have 0.0575 times 5 up in that exponent. So let's see, $1,333.09. cents. So really, really close to account 2. Account 2 is technically the best one though. So I would choose this one. So not by very much for the 5 years, but what happens is if you were going to leave this for 10 or 15 or 20 years, that difference, the difference between these would become more and more noticeable. So 5 years is fairly short. There's not a lot of difference there. This one, account 2, will end up being better and better the longer you would leave it in there.